Okay, so I got a request to do question 8D. The first part, question 8A, B and C, hopefully were straightforward enough. Just one thing to remember from them. And if they were successful with their previous throw, they were 0.8%, or the probability of them getting the next one is 0.8. If they missed their previous throw, their probability of the next one is only 0.6. So it must be a confidence game. Now in this question, it says to let P of n be the probability that Michael is successful with his nth free throw, and hence 1 minus P of n is the probability that Michael is unsuccessful with his nth free throw. Show that P of n plus 1 equals 0.6 plus 0.2 P of n. So you don't know if P of n was scored or not. P of n plus 1 means his next throw. So for example, if n was 10 there, the probability of his 10th throw, well, it would depend on his 9th throw. Likewise now, if n is 10, the probability of his 11th throw being successful depends on his 10th throw. So P of n plus 1 means the success of his next throw, and it therefore depends on his previous throw. So there are two outcomes. The probability of him scoring the next one is equal to the probability of him, so this would be his previous throw, this one, and this would be his Pn plus 1. So for example, that's his 10th throw, that's his 11th throw. So he scored his 10th throw, therefore the probability that he scores his 11th throw is more likely. Or he could have missed his 10th throw, so then how likely is he to score on his 11th throw? Now in the question it says that P of n is the probability that he was successful, so I'm just going to move this down now. So the probability of him being successful and successful. So P of n is the probability that he was successful. Therefore, if he was successful, the probability of him then scoring this one is 0.8. R means add. Therefore, 1 minus P of n is the probability that he was unsuccessful. It was given to you in the question. If he was unsuccessful with his previous throw, then the probability that he gets his next one is 0.6. So we multiply that by 0.6. So here I get 0.8 Pn plus 0.6, 1 times 0.6, and minus 0.6 Pn. Now, so then that gives me 0.8 Pn, take away 0.6 Pn is 0.2 Pn. Now I appreciate that's a difficult question. It's basically an algebra question, really, is what it is. And then assume that Michael's success rate in the long run, that is for large values of n, we have P of n plus 1 is equal to P of n, which is just basically equal to P. So it kind of averages out at some value. So what they're telling you there for the part 2 question is that, sorry now my hand is just taking up the available space here. So what they're just basically telling you there is that P of n plus 1 equals P of n, which is just equal to P. So using the results from part D above, show that P equals 0.75. So in this equation here then, P of n plus 1 equals 0.6 plus 0.2 Pn. So we're told that P of n plus 1 is just basically P. So we can substitute it in. Take this across now, so P minus 0.2 Pn equals 0.6. So you have 1P, take away 0.2P. So that gives me 0.8 Pn, and that equals 0.6. So Pn equals 0.6 divided by 0.8, which equals 0.75. Okay, and then just the next question, or the last part of it, it says for all positive integers, let an equal p minus pn. So therefore that would mean that an plus 1 equals p minus pn plus 1. So therefore, show that it's a geometric sequence with common ratio of fifths. So a to the n plus 1 then will be equal to p minus p to the n plus 1 over a to the n, which is p minus pn. And we already have, so p minus, so we've worked out p from the previous part. Remember the previous part here? We've worked out that p was equal to 0.75, so I can sub that in. Now, minus p to the n plus 1. We've worked that out in part 2. Remember, you were told to show that it was equal to 0.6 plus 0.2 pn. And then likewise, I have the p here again. So that's just 0.75 and minus p to the n. Now I don't have an expression for p to the n, but that's okay, because hopefully it'll cancel with this eventually, or it'll factorize out. Now, so 0.75 minus 0.6, that gives you 0.15, and then minus that, minus 0.2 pn, that's all over 0.75 minus p to the n. Now if you look at this, you have particularly in the bottom line, what can be factorized out in the bottom line? Well, if I factorize out 5, so just I'm going to factorize out 1 on the top line, and I'm going to factorize out 5 on the bottom line. So one whole thing divided by 5 is a fifth, or just 0.2 pn. So then these two things will cancel out and just gives me 1/5. So that's that done. Any questions, come back in the comments. It's more an algebra question than a probability question. That it wouldn't be something that I would overly worry about, because you're unlikely to get that exact same question again.